So guys, what are eigenvalues and eigenvectors? Uh, there are so many people who has like so many doubts about eigenvalues and eigenvectors. They know how to find out eigenvalues for a matrix and eigenvectors for a matrix, but they don't understand what it is. They cannot feel it. They cannot visualize it. So today I'm going to make you feel eigenvectors and eigenvalues. Okay. So what are vectors? First of all, a vector is something which has a magnitude and a direction, right? You know this from your 10th and 12th mathematics. So let's consider a 2D vector, two-dimensional vector, which has two coordinates. Let's take a vector u, which has coordinates 1, 2. Okay, and then v, which has coordinates -1, and maybe 1. Now if we draw these vectors, so what will be 1, 2? 1, 2 will be here. So this will be your u, and v will be -1, 1. So it will be here. So this will be your v, right? So these are vectors. Now the question is, what is eigenvector? What is an eigenvector? An eigenvector is a vector of a matrix. If you multiply that eigenvector with that matrix, it won't change its direction. The direction of that eigenvector will not be changed if you multiply that eigenvector with that particular matrix. It will just it might just change its length, but it won't change the direction. By this, what I mean is, suppose lambda is a eigenvector, is an eigenvector of matrix A, okay, and v is an eigenvalue. Sorry, my bad. It should be eigenvalue. Lambda is an eigenvalue, eigenvalue of matrix A, and v is an eigenvector of matrix A with respect to lambda, because there are different eigenvectors with different eigenvalues, So what I said earlier was, if I multiply this eigenvector v with eigenvector v, this is your eigenvector v, with the matrix A, the direction will not be changed, which means it will be v with multiplied by some scalar, some constant value, and which will be your eigenvalue. So let us visualize this. So suppose so let's take v as 2, 3. So 2, 3 will be here, and suppose lambda is maybe 1, 0.5. ठीक है. Now if you multiply a with this v, this one is v, right? So it will not change the direction, so lambda v will be, let's throw lambda v will be in this direction only, but 1.5 times of the length of v. This will be your lambda v, so it doesn't change the direction. Okay, this was your v, lambda v, or you can call it av, since av is equal to lambda v. So this is the meaning, it will not change its direction when you multiply this v with this this matrix. It will not change its direction, it will be in the same direction, but the length might be changed. Of course the length will also be same when lambda is equal to 1. In that case the length will be same. Now we can take an example. For example, let A is, we'll take a 2x2 matrix 1 2 0 2. So its eigenvalues are, you can find eigenvalues as determinant of this is 0. So one minus lambda 2, and then 0 2 minus lambda. So 1 minus lambda into 2 minus lambda equal to 0. So eigenvalues are 1 and 2. So you can directly, if a matrix is upper triangular or lower triangular or diagonal, the diagonal elements itself are the eigenvalues. You can see that directly, you can find out the eigenvalues, or you can calculate, or you can directly see that the diagonal values elements are the eigenvalues. So this is the eigenvalues. Now let's find out eigenvector related to lambda equal to 1. So lambda equal to 1, eigenvalues will be this, right? Now this will be 0 to 1 0 0 to 1 0, right? Yeah. And v, let's v is v1 and v2, right? So if we take v1 could be any value, and v2 must be 0. So you can take v1 as equal to 1, because eigenvectors are not unique. You can have so many eigenvectors. So final, the eigenvector will be 1 0. Now let's check it. Okay, let's check it. So here let's draw the let's visualize the eigenvector. What's the eigenvector? 1 0. 1 0 is this, right? This is v. Now if we multiply a with v, what was a? 1 2 0 2 with v, what we will get? We will get 1 0 only. So you see it remains the same, 1 0, it it means its direction remains the same, this direction only. It is also has same direction, right? Now let's check for lambda equal to 2. So minus 1 2 0. So from here we can find what could be the value of v1. V1, if we take 2, then and v2 is equal to 1, we can take. So v1 multiplies with this, p1 multiplies with this column 2, so minus 2, and v2 p2 equal to 1 multiplied with these 2, so minus 2 plus 2 0 and 0 0 0. So yes, this is the so the eigenvector is 2 1. Now let's visualize this. Two comma 1, right? So 2 comma 1 must be this 2 comma 1. So this is your v. Now if we multiply this vector with matrix A, what we will get? 2 comma 1, right? Now we get 2 4 and 2, so we get 4 comma 2. So what is 4 comma 2? 4 comma 2 is nothing but this. So you see the direction remains same, but the length of the vector has changed. It has increased by 2 times. Yes, eigenvalue is 2, that is why it has increased the length by 2 times. So these are the eigenvectors. It doesn't change its direction when you multiply with its matrix. Thank you.